Hi, hope you are doing good. And today's topic is Solow Growth Model that we'll be discussing today. So this model is an exogenous model of economic growth that analyzes the change in level of output in an economy over time as a result of changes in the population growth, the saving rate, and the rate of technological progress. So we'll see further. So let us start with the introduction part. So the Robert Merton Solow growth model focus basically on the long run economic growth, and as discussed already is an exogenous model of economic growth. Here exogenous basically is it relates to the outer economy factors that influence the economic growth, which is in the question here, which is we are going to discuss here in detail how it works and what are the factors and how they do affect. So this model was an alternative, or we can say the extension to the Harrod Domar model of growth. The Harrod Domar model was a very well known model of growth, and because that model assigned a crucial role to the capital accumulation. What is the role of capital accumulation in the process that was being discussed in the Harrod Domar model, and they emphasize the dual role of this capital accumulation. How in the one aspect they discuss that how new investment generates income, and that was been done or explained with the help of the multiplier effect, and the other aspect discussed that how it increases the productive capacity, which was actually been covered under productivity effect, and how this is done in the economy by expanding the capital stock. Now this model, the Robert M. Solow model or the growth model, this model ensured steady growth in the long run period, but without certain pitfalls which were found in the earlier discussed model or the Harrod Domar model. Also, Professor Solow assumed that the Harrod Domar's model was based on some unrealistic assumptions like fixed factor proportions, constant capital output ratio, and how that comes out, that we'll see further. Now, the assumption in this model comprise of the constant rate of reproduction and constant saving ratio kind of thing. We'll see the assumptions further. So these are the basic two things that he had taken in his model, and so it was shown here in this model that substitutability between capital and labor can bring equality between the warranted growth rate, the natural growth rate, and thus the economy moves on the equilibrium path of growth. I've already covered this Harrod Domar growth model on my channel. I'll put the link below, where you can see that how they discuss in their model this entire growth scenario in terms of three kinds of growth rate. So here they are trying to relate to the same, and further they established equilibrium considering all those three kinds of growth rates. Further, there are certain assumptions, of course, like any model has. So the first assumption is the production takes place according to the linear homogeneous production function with degree 1. Here you can see the function is y, where the y is output, which is equals to, or it is the function of KLN, which is is capital K and capital L, where the K is capital stock and L is the supply of labor force in the economy. So this assumption is considered to be the neoclassical by nature, and it assumes that there is a constant return to scale, which is based on capital and labor substitution or substitutability. I'm sorry, here I'm just little being stammering. Kindly excuse me here. So, and yes, the second factor is diminishing marginal productivities. So, these are the two reasons why it's been called as the constant return to scale production function. So, meaning to say that if all the inputs here are changed in a fixed proportion, then the output will also be changing in the same proportion. That is why it has been called as the constant return to scale production function. Just been shown here by multiplying a, which is a constant, on both the sides of the equation. So the equation will turn out to be ay equals to function will remain out of the brackets, and a will be multiplied both to k and l, meaning to say that there will be an equal and proportionate change on both the sides. Now assumption number 2 says that the relationship between the behavior of saving and investment in relation to changes in output, it talks about this, which implies that saving is the constant fraction of the level of output. So this way Solow adopts the Harrodian assumption. Here he took this assumption from the Harrod model, that investment is in direct and rigid proportion to income, which has been shown here in the symbolic terms. You can see I is equals to dk upon dt sorry, where k is the capital stock. It is the differentiation has been taken with reference to the time that can show the change in the capital stock, which is equal to sy, where s is the propensity to save, the tendency to save, and of course y is the income or the output in the economy. Assumption number 3 says that the growth rate of labor force is exogenously determined. The growth rate, it grows at an exponential rate, which has been assumed that the labor force is being growing exponentially. So if we assume that this population growth is constant, which you can see is being shown as in the symbolic form, it's been the change in labor force has been shown as to be equal to n, small n. So it implies that L is equal to L naught ENT. It is just to show that the labor, the population growth is constant, and it's been growing exponentially. L is of course where we know that it's the availability of labor. Further, and yes, n shows this small n here, it shows the constant relative rate at which the labor force is growing. Now other assumptions were like there is full employment in the economy. The two factors of production are capital and labor, and they are paid according to their physical productivity. How much they are being contributing in terms of their physical productivity, they will be paid accordingly. Then labor and capital are substitutable. I don't know why this word is causing me the problem every time I'm just pronouncing it. But anyways, so there is a perfect substitution, meaning to say, then investment is not of depreciation and replacement charges. Fine. Further, technical progress does not influence the productivity and efficiency of labor. There is flexible system of price based interest. I mean, meaning to say that everything rest is like constant or in a perfect proportion or in a perfect state. And the available capital stock is being fully utilized, as we already assumed that there is full employment in the economy. Now let us consider the first part. So here we'll see the role of saving investment in Solow Growth Model, which is the key component here. So as per this model, an increase in saving and investment raises the capital stock and thus raises the full employment, national income and product. Meaning to say that when the saving will increase, or we can say saving and investment increase, there will be an increase in the capital stock, and that increase in capital stock will raise the full employment, national income and the product. Meaning to say that the overall growth rate will increase as a result of this. So there has been a keen interest of economic policy makers always over the ways to increase how this can be done, how the saving and investment can be increased, how a very higher or an attainable growth rate or a targeted growth rate can be achieved. So in the short run, higher saving and investment raises the rate of growth of national income and product. So this is just an introductory part of the role of saving investment in this model. Now Solow analyzes how higher saving and investment affects long run economic growth. In the short run, higher saving and investment does increase the rate of growth of national income and product. Now as per this model, in contrast, higher saving and investment has no effect on the rate of growth in the long run. This is what been explained by this model. So for this, Solow set up a mathematical model which is based on the long run economic growth, because we are going to test the same. So it starts from here. The first part is constant population growth, that we have already seen that the model assumes that the population is being growing with a constant rate. We know that the labor force is being shown by capital L, which is the population, or I can say the part of population which is working. It grows at a constant rate. Small t represents time here. So wherever it is being taken, it is being taken with reference to time. So meaning to say that the change in labor or the growth in labor force is growing with a constant pace, which is being shown to be, which is being already we have seen that it is being shown with the help of small n. Meaning to say why this has been put in, so that if n is given to be 0.06, that would have mean that the population growth grows at 6% per year. It's just to show that like with what rate the population is growing, and it's been calculated as shown above, 1 by L multiplied by dl by dt. That is how n will be calculated. Now the investment part, which is the change in capital. So here the change in capital is being shown again with reference to time. It's dk by dt. So the change is being shown here, and I is the net investment part. It shows the change in the capital, which is capital K. Next, coming to the another part, which is saving. So here saving equals investment, which is already been assumed and been taken from the Harrodian part. So saving equals, or S, saving is being expressed as capital S, that equals the investment, which is I, capital I, is an accounting identity, and this saving is a constant fraction of national income. Saving is definitely part of national income. So it assumes that this saving is the constant fraction of national income, which is capital Y. So we can also say that capital S, which is saving, is equals to small s, which is the constant fraction part of Y, which is the national income. So as an accounting identity, national income equal to national product. So meaning to say that national income here is shown to be the national product, where this S or the saving part is a constant fraction. So then comes the aggregate production function. So what this production function, or sorry, the aggregate production function shows that the net national product, which is Y, capital Y, is a function of capital and labor. So this Y depends upon capital and labor. As we have already seen that the model considers only two factors of production, which is capital and labor. So this aggregate production function is kind of a fixed by nature. However, the product depends on capital and labor, does not change as time passes. That is why it's a kind of a static or the fixed aggregate production function. The consumption part. So this consumption part is, as we know that there is this equation, which is a very well known basic equation of economics, that consumption is definitely the national income. Whatever is not being saved or is being consumed becomes the saving part. It's a general assumption. So C here will be the part which is left out of national income, which is not saved. So consumption is equals to Y minus S. Y is national income, S is the saving. So whatever the basic assumption says that whatever is not being saved is consumed. So meaning to say that, and S we have already assumed that S is equal to I, which is investment. So this can be put in as C equals to Y minus S, which can also be put in as C is equals to Y minus I. Y is the national income, I is the investment, S is saving, and C is consumption. The assumption of full employment, we all know what full employment is. I've already discussed so many times in my earlier lectures. So as per this assumption, there is full employment in the economy, meaning to say that the capital labor, the main two factors of production, are fully utilized in production, in the production process. Constant return to scale, that we have already discussed earlier. It exhibits the constant return to scale, meaning to say that output will increase in the same proportion to the increase in the input. So if we double the capital and labor, the output will be doubled. So here what is going to happen now, the lower case letters, as you can see there is small y being used, it will denote the per capita amount. Since we are going to work further on the equation part, so this is how it will be used. So the lower case will show the per capita amount, whether it's the income part or the capital part or the consumption part. Now the intensive production function, as we already know that we have assumed that there is constant return to scale, or we can say the return to scale are constant here. Output per capita, that we have already seen how it will be denoted. It can be expressed as the function of capital is to labor ratio. As we know that small k is equals to capital K upon capital L. So therefore the y, which is small y, which is the per capita income or output, will be the function of small k, which is nothing else but the ratio of capital is to labor. Now here this Fk, meaning to say the ratio of capital is to labor, is an increasing function of small k, that is being shown in the figure in the upcoming slide. So here the law of diminishing marginal return will apply, and after a point of time this k will start decreasing. Like here you can see this is y, the output part, this is the capital part. As we can see that the graph is going upward and further coming at this point, it further starts declining here because of the law of diminishing returns that we have already seen, that we already know, that is being discussed in quite a detail. So because of the application of that phenomena, what happens that it start increasing with a decreasing rate, that is known as the diminishing return. That is where the point, that is after a point of a particular peak, it starts diminishing. So that is how, and that is why this graph is little, you can see it's been going down little from here. Further, if it extend it further, it will go down here towards the x-axis. Now the national income and product per capita. So here this small is the this is small y is the as we have seen that the lower case will always denote the per capita part. This small y is equals to the capital Y, which is the national income, upon the capital L, which is the labor force. Now as we have already seen that y depends upon these two factors, k and l, capital and labor. Further this can be worked out, which will give this part, and this can be further expressed as small f upon within the bracket it's k upon l, which is equals to this k upon l is nothing else but it can be written in the lowercase part, where this lowercase k or the small k denotes, we have already seen it denotes the capital is to labor ratio, and since it's the constant return to scale, that is why this the third equal sign denotes that. Now another part, which is another very important part, there are two concepts basically where we can say that the capital accumulation, we have already seen that capital accumulation do influence the growth rate of economy very well, and it's quite a strong influencing factor here to govern the growth rate. So now what is this capital accumulation here? So in the model it's been discussed that this can be decomposed into basically two parts, which is capital deepening and capital widening. So what is the difference? Capital deepening is increasing the amount of capital per worker. That is the capital accumulation that permits small k. We know that it's the denotes the capital is to labor ratio. So this is that capital accumulation part that permits small k to grow. This we'll see further that it's been mathematically represented as capital L dk upon dt, where k is the capital, t is time, and L is labor. So it is basically increasing the amount of capital per worker. How much amount of capital has been increased per worker? Capital deepening shows that part, whereas capital widening is equipping of new workers with capital. So here you can see the basic difference is that the earlier the amount of capital is being adjusted, whereas in the second part new workers, there is a labor force that is being adjusted as per the available capital. So as population grows, this is how much of the new workers are being equipped with, how much is the new labor force which is being equipped with available capital. So capital accumulation requires to keep k constant as labor, meaning to say that it is that capital part that requires to keep k constant as L grows, meaning to say to keep the capital part constant, or we can say the ratio of capitals to labor constant as the labor force grows. Mathematically it's been represented like this. K is the capital, or we can say that's the ratio of the capitals to labor, L is the labor force, and T is the time. Now let us see the further derivation is the decomposition part, where K is equals to, K denotes the ratio of K is to L multiplied by L, which is labor force. This K to L is nothing else but the small k part that we have seen already. So this expresses capital, this is the first equation part, it expresses capital, this capital as a product of capital is to labor ratio and the labor part. As we have seen this capital accumulation, which is nothing else but change in investment, the capital accumulation, which is the level of investment that shows the change in capital with respect to the time. Now it must affect either K or L. K is again the same thing we have already discussed, and L we know that it's a labor force. Now what happens if we differentiate this equation here? What happens here? We can say differentiating that decomposition equation number 1 with respect to time. If we differentiate it, applying the product rule of differentiation, equation number 2 comes out. Now further what happens, what here the equation is showing, this part is the capital accumulation part. It is the summation of the capital deepening part that we have already seen, how capital deepening part is being shown, plus the capital widening part. So when we differentiate that equation, this equation number 2 comes out to be the capital accumulation equation that shows that it is the summation of the two parts and how it's been decomposed, we have already studied that how capital accumulation is being decomposed into two parts. The first is capital deepening part and the second is capital widening part. So this has been done with the help of differentiation and applying the product rule of differentiation. We get this concept in the mathematical form. Now there is a very simple numerical example being given here, where you are supposed to only put in the values and calculate the small k. You can see it, and if there is confusion in this part, you can simply write in the comment. I can explain this, but this is nothing else but all these values are being given here. so the capital ratio part is where you only put the values here, like capital is been put in here, and then labor has been taken as 100 and small k comes out to be 10. So since small k comes out to be 10, now increase in labor, which is the growth rate of labor, n times the total labor, which is NL. Here we'll put the values again, as we have seen. N is already given to be 0.10, L comes out to be 100, then the value comes out to be 10. We'll put the values here to find out the value of that, how much of workforce. I mean, we'll put the values here in the equation, the basic equation that we have just come out with, to find out this part. Whereas we have already got dl by dt. Further here dk upon dt is already given, so we'll put in the equation and we'll find out this k dl by dt. The value comes out to be 100 when we put in here, which shows that to equip 10 new workers with capital, it requires 100 of investment. The currency can be put in as per the region or the wherever. So this is how it's been done. Whether the capital deepening part is needs to be find out, or the capital widening part needs to be worked out. This is how it will be calculated. So it was just to show with the help of this simple example how this can be done. Now further in this equation, we have already find out the capital widening part, as you can see, and further putting all the values in equation number 2, what we can find out is the capital deepening part. So it's nothing else but simply to show that with the help of that equation and the values being given in the numerical, how we can find out the total capital accumulation part in the economy once we find out the capital deepening and the capital widening part. The same is being continued here. So this comes out to be that how this is dk by dt, showing that the capital labor ratio is increasing by 3 per year. So it's just to show that how other values can be worked out with the help of the basic equation of capital accumulation, just being by putting the values here. Now further capital deepening and widening per capita. Here again that equation number 2 is being taken, which was here, which has been little just to remind here, has been taken already here from that slide. This was equation number 2. So what was being done here, that the equation has been divided by L on both the sides, capital L. So this comes out to be this final form, which is dk by dt plus kn. So in this equation, the left hand side is saving and investment per capita as per assumption number 2, which says that I is equals to dk upon dt, and this is nothing else but sy. So the value has been put in here, and so this part comes out to be this is taken as directly here, and this whole part is being converted in from the assumption, is been converted using the assumption part. So this part is being taken as sy. The L will remain here, and this y upon L is nothing else but the small y. So this turns out to be sy, small s multiplied by small y, where y depends upon the capital part, which is the function of capital that we have already seen in the model, the derivation in the earlier derivation part. So we'll put fk instead of y here. So this whole part becomes equal to sf and the s multiplied by the function of small k, which becomes the equation number 4. Now what we'll do, that we'll combine equation number 3 and equation number 4, meaning to say this part and this equation and this equation. So what it gives, working out a bit what happens here when we combine those two equations, the fk part comes out, and this further works out to be this. No, so now what is this part? This is the saving per capita, which is equals to the capital deepening per capita, dk by dt, plus the capital widening per capita, which is k, small k and small n. So this is equation number 5. Now if we little rearrange this equation to find out the dk by dt part, it comes out to be sfk minus nk. Now next figure in the upcoming slide is the where the curved line will be showing the saving per capita, meaning to say this part, and the straight line will be capital widening per capita, which is nk, and the vertical difference between the two is the capital deepening per capita. Here you can say this is the sfk, which simply we can say that is the saving part. Then this is the nk, where the this is the capital growth ratio versus the multiplied by the rate of labor growth. The output is to capital ratio is being taken on y axis, and the small k, which is the capital out then again the capital output ratio, capital labor ratio is being taken on y axis. You can see that this curve, this sfk or the saving part, increases up to a level, and at this particular point it cuts this straight line, which is why it's been taken as to be the straight line, because we have already assumed that the labor is growing with a constant rate. So now this saving part, it comes here and it cuts this straight line curve here, meaning to say at this particular point there will be an equality between the two. Right from here, if we draw a perpendicular, this point becomes our k bar. As you can see, the curved line is the saving per capita, sfk, straight line is capital widening per capita. So the vertical difference between them is the capital per capita, which is dk by dt. Vertical distance between the two is the capital dk by dt, the capital widening part. So now what happens when the k for a lower value of k, what happens? K increases further, this part. From here it increases, it's increasing, but then after a point, and why it's been increasing here? Because rising part shows that there is more than enough saving to equip new workers with capital. On the other hand, for high k, like here, when it comes here to the point of the we can say the topmost point where it reaches its highest level, then it starts falling. Then or we can say further here, even it becomes equal, and further it goes up to this point, and then from here it will start falling. So what happens? It shows that in the long run the capital labor ratio converges to k bar. Saving is why it's so? Because saving is just sufficient for capital widening, and there is no investment left over for capital deepening. So what happens here? It comes to the equality part, which is sustainable, and this is that is why it converges to this point, which is k bar, where it is showing the equality, which is quite sustainable, because after that the saving part starts reducing, this sfk starts reducing, so that will be an unsustainable situation. Now let us talk about the long run steady state, which is another part of this model. In the long run, what happens? There is a steady state economic growth as per this model, since the capital labor ratio is constant at k bar that we have seen in the graph itself. Now as labor grows at the rate small n, necessarily capital k or the capital grows at rate n, because return to scale is constant. So national income, product, capital Y, saving and investment, which are equal to each other, and consumption all grow at rate n, at the same rate. Now income and product per capita Y and consumption per capita small c per capita, since this has been shown with the lowercase rate lowercase, small y and small c, they are also will be constant because of this thing. What happens in terms of real interest rate and real wage? Now if the economy is a competitive market economy, the real interest rate is what is the real interest rate? It is the marginal product of capital. And similarly, what is the real wage? It is the marginal product of labor. As we have already seen that both are being shown as per their productivity and the contribution to the economy. Now since the capital labor ratio is constant in the long run steady state that we have just studied, the marginal product will also be constant because it shows the marginal difference or the incremental change, one additional unit of change. So that will also be constant. And hence the real interest rate and the real wage rate will also be constant. Now what happens when there is a change in population growth rate? If we refer to that equation that we worked out, equation number 6 here, the rate of population growth sets the long run growth rate of economy. Now if the population growth rate n rises, the capital widening term nk will rise. Consequently, the steady state capital labor ratio, which is k bar, this falls. Now what, since the capital widening part is increasing, the capital is to ratio which comes out to be the equality part being shown by the k bar, it falls. Now since this k bar falls, the steady state output per capita will also fall. In the steady state, the real interest rate is now higher because this is higher, but the real wage will be lower because of the fall in this output per capita. So this happens when the population growth rate increases or it rises. Now what happens with the change in saving rate? What happens here is the saving rate S does raise the rate of economic growth in the short run, that we have already seen in the earlier growth model. They says this, but this model says that it has no effect on the rate of growth in the long run. The higher value S does raise the steady state capital labor ratio, which is we know it's the k bar, small k bar. Hence the steady state output per capita rises. That is how. And in the steady state, the real interest rate is now lower and the real wage rate is higher. When this happens, when this part increases, what happens? That this part will become lower and this will be higher. That leads to the higher value of this part also. So both the things are being taken into consideration, showing that what happens if this part increases and further what happens when this part increases. These are a few sources that I referred to. Thank you for watching. I wish you good luck. Thank you.